All right, I have a little bit of a bonus problem to try to help you understand how to solve some inequalities. So, for this one, we are going to have to do a little bit of simplifying, some inverse operations, just a lot of different things. First, I want to take care of whatever I can simplify as best as possible. I see this negative sign. In my head, I automatically think distribute. So something that some people like to do is they like to put this 1 here because it's really just a -1 being distributed. So it's a -1. We distribute to all of this. So the next line is really 14x minus 12 divided by -3 plus 5 less than 2x minus 5 minus x. It flips the sign. Both are positive, now they are negative. Now we have to combine some like terms. Well, what are my like terms over here? Well, I got a 2x, I got a -x. So I'm combining the things with the same variables, the same exponents. That's what like terms is all about. So I'm going to combine some like terms. So I got 14x minus 12, all divided by -3 plus 5, still on that same side. But these become x minus 5. So now we got to work to get our variables together and our other elements together as well. I want to try to get this fraction to be as simplified as possible. The way I'm going to do that is I'm going to move some things around. So here we're adding 5. Okay? Why do I need to make sure that I deal with the 5 before the -3? Because inverse operations means I have to deal with the opposite of what the order of operations are. So an order of operations tells us that we really should do our multiplication division first, then our addition subtraction. But not here. But wait, Mr. Collins, why don't I subtract 5 and add 12? Well, the problem here is if you have something on top of a fraction, it stays together until you get rid of that thing on the bottom of the fraction. So let's try to take it one step at a time. Here we go. Addition. We're doing addition before division because the addition is the opposite. We're doing the opposite of order of operations, not addition, not multiplication division. Addition and subtraction first. Let's subtract 5 from both sides. This becomes x minus 10. And here it becomes 14x minus 12. Again, you don't want to add 12. Why? Because this is together. You need to get rid of this -3 first before you can do anything like that. So we are going to multiply by -3 on both sides. I get 14x minus 12. A couple things are going to happen here that are very important. If I multiply by -3, is it fair for me to multiply just the x by -3? No. What about the -10? No. Wait, you mean I have to do both? Yup, you got to do it to both. So you get -3 times x minus 10, which then becomes 14x minus 12 is less than -3x plus 30. Has anybody noticed a crucial mistake that I made here? I made a very crucial mistake. Here is my crucial mistake. I forgot to put the x, but when I have to multiply or divide by a negative, I have to make sure that I flip the sign. I didn't do that before. That's very important. Multiply or divide by a negative number. Flip the sign. It changes the value of both sides of it. Okay, now we got to combine some like terms. Plus 3x is 17x minus 12 greater than 30 Add 12 to both sides. I get 17x is greater than 42. Divide both sides by 17. I get x is greater than 42 over 17. Yuck. That is a messy, messy, messy fraction, but it's still correct. Okay? When I plot on the number line, looking for numbers greater than 42 over 17. So that means it has to go this direction. And it also has to be an open dot because it's not included. It's not equal to. Again, open to the right.